Alright guys, we are now on lesson 3.4 using the quadratic formula. So you should be familiar with the quadratic formula as you learned it in Algebra 1. We are going to take it a little further now that we've talked about imaginary numbers. So we're going to look at some different types of solutions that you would get with quadratic functions. And we're going to start off by how you learned it in Algebra 1. So this is the same way you learned it in Algebra 1. So we're going to solve an equation with two real solutions. The one thing that you have to note is that you need to make sure your equation is set equal to 0. If it isn't, then you need to make it equal 0. So in this case we have 5 on the right, so we need to move it to the other side by subtracting it. So we're going to say x squared plus 3x minus 5 equals 0. Alright, so now in order to use my formula, I need to know what my A, my B, my C values are. And if you forget where they're located, you have this equation right here in standard form. So let's set it up over here. So our A value, if there is none, there is 1. So our A value is 1. Our B value is right here, so that's 3. And our C value is our constant, which is negative 5. So if you have negatives in front or subtraction signs, make that a negative number. Alright, now we're going to just take these numbers, plug them into our equation. So we have x equals negative b, which is 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a times c, all over 2a, so 2 times 1. Alright, so now we're just going to simplify. So let's just simplify. We have x equals negative 3. Can't really do much with that. Plus or minus. So now we're going to simplify what's inside. So we got 3 squared. That's 9. Alright, now we're going to multiply all this together. So we're going to treat this like a negative. So negative 4 times 1 times negative 5 would give us positive 20. And then over 2 times 1, which is 2. Alright, so now we're going to simplify a little more. So we have x equals negative 3 plus or minus the square root of 29 over 2. So we want to look at 29 and ask us, can we simplify this any? And we can't. There's nothing that we could multiply that's a perfect square. So we're just going to rewrite our solutions with our plus and with our minus. So our solutions are x equals negative 3 plus the square root of 29 over 2, and x equals negative 3 minus the square root of 29 over 2. So those are both of our solutions. So maybe you're asking yourself, alright, Ms. Gill, okay, so I did the quadratic formula, who cares? Like, what does this mean? So this means that your graph intersects the x-axis at these 2 points. So do we know these aren't whole numbers, but if you were to put in a calculator negative 3 plus the square root of 29, then divide it by 2, that would give you one of the x-intercepts, and this would be your other x-intercept. So remember, that's what you're finding when you're solving these. You're finding where does the graph cross the x-axis, so you don't have to actually look at a graph. Alright, so you know how you guys love extra credit. Alright, so with this lesson, you may have more than one opportunity, but if you would, on a separate sheet of paper, answer this question and give it to me when you are asking for this practice to be released, and I will give you some extra credit points. Alright, moving on. So, solve using the quadratic formula. Alright, so I just want you guys to try number 2. If you want to go on and try number 3 as well, please give it a try. You can try as many of these as you want. I will put all of the answers up for you. So if you haven't already, please pause your video and give at least one of these a try. Okay, so here's the first one for you. So your solutions are right here. All right, notice that in this situation we did get the square root of 20, and up here I showed you how I went from the square root of 20 to the square root of square root of 5. And remember, we're looking for perfect squares, so we're not using our calculator to turn this into a decimal at this point. How do you know the difference? They will tell you round to the nearest tenths place or hundredths place or something along those lines. If it doesn't say that, then you have no idea where to round to, then you leave it in radical form. Okay? All right, so hopefully you got this answer. If you did not, please try another one. All right, and if you did and you feel comfortable with this, you can skip to the next example. All right, but if you would like to try more, I will come back with the answers to the other two in a moment. Don't forget to move your stuff to the other side to make it equal 0. Okay, so here we go. Here are the answers to the other two if you gave them a try. For the last one, I could not find a perfect square that was a factor of 161. If you think you found one, please show me, let me know, and I'll give you extra credit if you found something that I didn't. All right, anytime, if I make a mistake or something like that, guys, I'm willing to give you some points for coming to me in a polite way and be like, hey, Miss Gill, you did this, because some of y'all already done that, so I appreciate it when y'all aren't rude about it. All right, let's move on to the next example. So hopefully you remember this from Algebra 1. So how is it different now that you're in Algebra 2? Well, we have different types of solutions. So notice example 2 says, solve an equation with one real solution. So what does that mean? That means we're going to have one x-intercept. Again, you have to make sure your equations are set equal to 0. I didn't mean to put x there, I guess because I was writing x before I meant set equal to 0. All right, so we're going to have to do this as well. So we're going to have to subtract the 12x from 8x and then add the 4. All right, so now what do we get? We have 25x squared, negative 8x, and negative 12x gives us negative 20x, and then we have plus 4 equals 0. Alright, so now we're going to set this up using our quadratic formula. So we need to list our a, our b, and our c values. So go ahead and do that. Alright, so in this case our a value is 25, b value is negative 20, c value is positive 4. So now we're just going to set it up into our equation like we did previously. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Alright, now we're just simplifying. So if you want to go ahead and try simplify it and come back to the video, you can. So if I put 20 squared into the calculator, I get 400. Because remember, negative times a negative is a positive, so I don't even have to put that in there. Alright, and then I'm going to do minus, and we need 4 times 25 times 4, and that also gives us 400. And that is going to be over 2 times 25, which is 50. So now, what happens when we take 400 and we subtract 400? I'll move this over here. So we end up with 20 plus or minus the square root of 0 over 50. Well, what's going to happen here? Square root of 0 is 0. So we're just going to drop the 0 and we're left with 20 over 50. Can you simplify 20 over 50? You can. They're both divisible by 10, so we can cancel out those zeros, and we would be left with 2/5. So in this case, our solution is x equals 2 fifths. So they told us in the title that we were only going to have one real solution. So what does this mean? Well, again, finding the answer to this problem tells us where a graph crosses the x-axis. So how many times is it going to cross the x-axis? One time. All right, and that point is going to be 2 fifths. So most of the time that means that your vertex is just sitting on your x-axis. All right, so like you would have your x-axis like this, and this one would be 2 fifths, so it would be somewhere like that. So it would just be sitting on the x-axis. All right, so I want you guys to try some. Give me just one moment. Never mind, I changed my mind. We're going to go ahead and look at example 3. So example 3, now we're going to pull in the new part. So this is the new part with the quadratic formula. We're going to solve this using the quadratic formula, and we're going to find 2 imaginary solutions. So what does that mean? That means we're going to have I in our answer. Okay, so what does that mean? That means in order to have I in our answer, our square root part is going to be negative. So let's see how that works out. So we do need to move this 13 to the other side. So we end up with negative x squared plus 4x minus 13 equals 0. All right, now we need to list our a, b, and c values. So our a is negative 1, b is 4, c is negative 13. All right, and remember, if there's none, there's 1. So in order for this to be negative x squared, it had to have 1 exist. It's just not necessary to write the 1. Okay, so let's plug it into the formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And now we're just going to simplify. So we have negative 4 plus or minus 4 squared gives us 16. We have a negative 4 times negative 1, so that would give us positive 4. Here, I'll show you in the calculator. So let's go with, because remember, we're treating this minus 4 like a negative. It'll make your calculations so much easier. So negative 4 times negative 1 times negative 13. And that gives us negative 52. So 16 minus 52 all over negative 2. So now we want to simplify even further. What is 16 minus 52? That gives us negative 36 over negative 2. So here is where our imaginary number comes into play. So remember, if you have a square root of a negative number, your answer is I. And then what is the square root of 36? If you said 6, you are correct. So let's continue down here. So we have negative 4 plus or minus, we're going to work this out. So we just said that was 6i over negative 2. All right, we can simplify this a little further and write our final solution. So because we have a negative over a negative, we can divide. So we can actually separate these two. So I'm going to separate them just so you see what I'm doing and you don't think I'm making magic happen. So all I'm doing is just like, remember when you learn to add fractions, you combine your numerators, put it over the same denominator. So I'm doing the same thing but reversed so we can simplify. So for example, negative 4 divided by negative 2 gives us a positive 2. 6 can also be divided, and so that's going to give us a 3i. So we're going to have 2 plus or minus 3i. All right, the negative is okay because we already have a plus and minus there, so not a big deal. So we can now state our final answer. Our solutions are x equals 2 plus 3i and x equals 2 minus 3i. So what does this mean? All right, why did we find this? Well, this means that even though a graph for this equation exists, when you graph it, it doesn't cross the x-axis. Right, so it's not that there's no equation that works. The equation, you can graph it. It's just it never crosses the x-axis. So in order to be able to solve this, we would use our imaginary numbers. to answer it. So that way we actually get a solution. Okay, now I want you to try some on your own. Alright, I want you to try these on your own. You can pause the video. I'll do one and come back, and then I'll do the rest, kind of like the previous one. So this one ended up having two imaginary solutions, which is what you need to practice anyways, because that's really the new part to this. Okay, so hopefully you got that as your answer. If you did and you feel good about these and you want to, I think I'm going to end the video after these, so if you want to move on to the next example, you can. However, if you need some more practice, please pause the video and try the other two. I will come back with the answers to those two. So if you need a little more practice, please try them. Okay, so this one was one where your square root came out to be 0. So then we're just simplifying. Just wanted to let you know that how to go from here to here. I divided both by 6. Remember, you can use, if you don't see the greatest common factor, you can use a smaller one and just keep simplifying until you can't simplify no more. Okay, come back if you want to see number 7. Okay, here is the last one. So I put a couple of notes here for you. When we got to this part, I worked out the square root of -48 over here. You get 4i square root of 3. So that's how I got this. Then I simplified by 2. So each one of these numbers you could divide by 2, and that's how I got this. Now your denominator is negative. I just pulled the negative out in the front when writing my answers. Could you write it here? Sure. It shouldn't mark it wrong. Alright, so hopefully you're finding this not too bad. Come back to the next video to finish this lesson up.